So guys, today we're going to be revising all of stoichiometry from beginning to end. There are a couple of important formulas we need to know. Alright, so our first formula we need to know is our n is equal to small m over big M. Right? Guys, remember this one? What does n stand for? I'm going to make a summary on the side here. N is moles. What is little m? Mass. In grams. Alright, big M. Molar mass. Measured in grams per mole. Alright, that's our first formula. Next, we have our. Okay, now I'm not going to be going in order because after we have this one, the others can just follow in whatever order. Alright, so I'm going to write, this is our summary, here's our formulas. N is equal to little m over big M. And we have C is equal to N over V. What is C? Concentration. Measured in? What's concentration measured in? Be careful with my phone. Alright. Alright, so guys, quick trick if you can't remember your units is use this. What is moles measured in? Moles. Volume is measured in? Decimeters cubed. Alright, I take this to the top. And that's how I get my units. Mole per decimeter minus 3. Alright, do you see that? That's how I get my units. If I can't remember them. And I have volume, which is decimeters cubed. Alright, we're happy so far? Following, this is easy so far. Alright, next we have our let's say n is equal to n over NA. Alright? What is our big N? Thank you. Number of particles. And NA is our Avogadro's constant. Alright, next we're going to do N is equal to V over Vm. Alright, N is, V is volume, Vm is my molar volume. Alright, what other formulas do I have? Is that all of them? I think that's all of them. Alright, so now that we have that, I'm going to write down our stoichiometry recipe. Do you guys remember our stoichiometry recipe? What is our stoichiometry recipe? What's the first step? Convert to moles. Step 2. Step 2? Ratio. Use ratio. Step 3? Convert to what you want. So what I'm going to do now is I'm going to go through some examples in the back, in the exam questions section of your textbook. Because those are normally a little bit harder. question 5, page 304, the Accenture textbook. Alright. Q5, page 304. Do it in a different color. Alright, so my question says 2 grams of magnesium react with 0.65 grams of oxygen. Alright, so I'm going to write out our question. 2 grams magnesium react with 0.65 grams of oxygen. Oxygen. It forms magnesium oxide. Alright. 5.1. Give the balanced chemical equation. Alright, so there's something special about this. Obviously we know magnesium, we can just write as magnesium. Grab a hospital. So magnesium we can just write as magnesium. Mg. Now oxygen. How do I write oxygen? O2 because it's a diatomic molecule. So plus O2 gives me, now I need to use my, as I've discovered, oxidation numbers. That's what I've written on top of my table. I did not know that until I taught redox, but now I know those are my oxidation numbers. So I'm going to use those numbers that I've written on top of the periodic table, alright, to balance my magnesium oxide. So I have Mg, which is 2 plus, and oxygen, which is 2 minus, which means it just makes MgO. Now I need to balance, I need to times that side by 2, times that by 2 over there. Alright, you're happy with how I balance my chemical equation? Alright. Question 5.2. We're going to skip. Question 5.3. Determine which reactant is in excess. Okay. More of a challenging one. Alright, so this will be a 5-mark question. So if we're determining what reaction will be in excess. So our first step is the same as always. What's our first step of our stoichiometry recipe? Convert to moles. Alright, so I'm just going to take magnesium, I'm going to convert it to moles. So I'm going to say for magnesium, N is equal to M over capital M, gives me 2 over my molar mass of magnesium, 24. Yeah. 24, which gives me an answer of 0.08. Alright, 0.08. Alright, and that's my moles. Right, what's my next? Yeah. Alright, so this is our relative atomic mass. Alright. So the 24 is our relative atomic mass. So here our molar mass is our relative atomic mass added together. Alright, our relative atomic mass added together. So for example, if it was O2, it would be 16 times 2. Alright. And then, what's my step 2? Use my ratio. So, I want to know which one is in excess. magnesium or oxygen. So that's the ratio I'm going to use. So I have 2 as to 1, and this is my magnesium as to oxygen. So now I say 0,08 as to what?
0,04.
Alright, this is over x. Alright, so I say 2x is equal to that, which gives me x is equal to 0,04 moles. What's my next step of my stoichiometry recipe? Convert back to what I want. What do I want? Grams. Right? I want to know how many grams of oxygen I was supposed to use. Right? So I'm going to convert back to what I want. So now I say oxygen is equal to N is equal to M over capital M. 0,04 is equal to my mass over my 16 times 2. Alright, you happy with that? Alright, which gives me an answer of mass equal to? Sorry? 1,28. Alright, so now is where I'll answer my question. So already you have 4 marks. Just by following your stoichiometry recipe and not knowing what on earth we're doing. All I did was follow my stoichiometry recipe. I already have 4 marks of this question. Do you guys see that? That's why this recipe is so important. So now it says to me, let's look at our question again. Which reactant is in excess? Alright. So which one do I have too much of and which one do I have too little of? Alright. So I have 2 grams of magnesium. Alright. And I have 0,65 grams of oxygen. Well, how much oxygen did I work out we would need if we had 2 grams of magnesium? 1,28. Which means we don't have enough oxygen. Do you guys see that? So which one's in excess? Magnesium. There's my answer. Mg is in excess. Alright, so basically what I said is, I worked out if 2 grams of magnesium reacted, how much oxygen would I need? And I worked out that I need 1,28 grams of oxygen. But I didn't have that much oxygen. I only had 0,65, which means I didn't have enough oxygen in my equation. Alright? Which means my magnesium was in excess. There was too much magnesium and too little oxygen. Because remember, excess means too much. Alright. So my magnesium was in excess because there was too much magnesium and there wasn't enough oxygen. Alright, so you guys happy with that? Alright, so I'll show you where your 5 marks go. 1 for formula, 1 for correct substitution, 1 for using your ratio, 1 for correct substitution, 1 for magnesium is in excess. Yeah, that's 5 marks. Alright, does that make sense? Any questions about this? Must I go through it again? Alright, so let's look what the next question says. Determine what is the mass of the substance in excess? Alright, so how much mass is in excess? What is the mass of the substance in excess? Now let's write this down, 5.4. Alright, so now, I want us to look at this question. I know often the problem with stoichiometry questions is that the question itself is confusing, right? So now, this is confusing because it says, what is the mass of the substance in excess? So, the substance in excess was magnesium, and the mass was 2 grams. But if this is a 2-mark question, are they going to give me 2 marks for simply reading out of the question? No, they won't give me 2 marks for just reading, doing comprehension style, which means I have to work something out. So this is how I'm analyzing my question when I get it. I don't know what they're asking for, but I know they wouldn't ask such an easy question, not such a comprehension style question. When I say comprehension, I mean, let's read from the passage and find our answer. Right? It's too easy. Science isn't that easy, unfortunately. So what they're going to ask for is they're going to ask how much is in excess. Okay, does that make sense? So, here I worked out that oxygen there was 2 little oxygens. Now I need to work out how much magnesium should I have had. Alright, does that make sense? For it to react correctly. Okay, so I'm just going to work this out again. So my answer starts. Alright, so what's the first thing I do? Moles. So this time I'm going to take oxygen. I'm going to convert it to moles. So N is equal to M with a capital M. So you wouldn't need to do this if you had used magnesium in the start here. But since we didn't, we're just going to write it out again. Alright, so magnesium gives me N is equal to my mass of 0.65, my molar mass of 16 times 2. Gives me an answer. Zero comma 0.08. Am I wrong?
Yes.
Zero comma 0.02. Yeah. Yeah. What's up?
What is 0.65?
That's the mass of oxygen that I gave me in the question. Okay. But no oxygen is in the right amount. If that makes sense. It was not in excess, so we have the right amount of oxygen. So I want to work out what the right amount of magnesium was. Okay. So then I use my ratio. We have 2 as to 1, magnesium as to oxygen. So I have 0.02, which means this would be 0.04. Now I'll work it out again. My magnesium is equal to M over capital M. So that gives me 0.04 is equal to my mass, or my molar mass, which was 24. .96, so my mass 0.96. So that's how much I should have had. So my excess will be 2 minus 0.96. 1.04 grams. Okay. Alright guys, do you know what it means when something's in excess? Yeah, I'm just sitting here assuming you know what it means. So think about, my best example is, have you guys played with spirit vinegar and bicarbonate of soda?
What is it?
Baking soda. Spirit, you know, that white vinegar and baking soda. Go home and play with it. I'll even send out an email to your parents saying that this is an instruction from your teacher to go home and play with the vinegar in your cupboard and the baking soda. Not baking powder, baking soda. Alright, when you mix them, they fizz. But sometimes I'll put too much baking soda in, and then after it's finished fizzing, I'm still going to have some granules of baking soda at the bottom. That means baking soda was in excess. If I don't put enough baking soda in, then I'm going to smell it, it's still going to smell like vinegar. That means my vinegar was in excess. Does that make sense?
Yes, ma'am.
Okay. Alright, you guys want to take a picture of this and I'll go on to our next question. Okay, this is another good question. It's a little bit different, but still can be asked. It's a little bit more application for a couple different things. So this is question 10, page 306. Alright, so it says a gas forms in the following chemical reaction. Alright, so it gives us a chemical reaction. Alright, 10.1 says balance the reaction and indicate the states. Alright, so let's start by balancing our chemical reaction. Alright, on this side I have one hydrogen. Nitrogen, oxygen, calcium, carbon. This side. Let's write them in the same order. So the way I calculate my oxygens is I say 3 times 2 gives me 6, 7, 8, 9. 9 oxygens. Right, so now the first thing I see here is that I need 2 nitrogens and 2 hydrogens. I'm going to go here and I'm going to add my 2 nitrogens and 2 hydrogens. I have my 2 over there, which now gives me 2 hydrogens, 2 nitrogens, and now I've got 6 oxygens plus 3 oxygens gives me 9 oxygens. Look, now it's balanced. Alright, so you guys happy with how I did that? Alright, what I generally do is I'll look at one of my more unusual elements, so not a carbon, hydrogen, or oxygen. I'll look at a nitrogen or a calcium, alright, and see, are they out of balance? And if they are, then I'll go back and balance that, and you'll see that's how it can progress forward quite easily. Okay. So now it says indicate the states. Alright? So what is this? What's the name of this?
Gas. Nitric acid.
Nitric acid. Acid will be?
Liquid.
Aqueous. Remember, our only liquid is water. All the rest are aqueous. Calcium carbonate. Solid. Alright, it's a precipitate. Alright, we know calcium reacts with carbonate, produces a solid. And this is calcium nitrate, right? Okay, calcium nitrate. Solid or aqueous?
Solid.
Possibly, I'm not quite sure, we can check. Water is our liquid, so remember water is our only liquid. And carbon dioxide is our?
Gas.
Gas. Okay. So in your guidelines, you remember how I said to you that they can ask tests for gases. Remember how I had that extra lesson on it? Right, so that means they can ask a question like this. Alright, so it says, name the gas that forms. Well,
Carbon dioxide.
carbon dioxide, yeah. I'm going to write this over here, 10.2. Alright, so when I say name, that means I have to actually give the whole name of it. I can't just write CO2. Alright. I have to write carbon dioxide. So name means carbon dioxide. Alright, how can you test for this gas?
You put it in the liquid. You put it in the
Alright.
tank.
How do we test for this gas?
Oh, the match was
That's not the one I want. There's a different one that I want. No, certain kind of water.
lime water.
Yeah. Alright, 10.3. How do we test for this gas? to test for this gas. Lime water. What happens to lime water?
Turns white.
Turns milky. Alright. Lime water turns milky. So, we bubble through lime water. The lime water turns milky. Alright, that's the answer they want for testing for carbon dioxide. Alright. That is the correct answer for testing for carbon dioxide. Okay. Alright, what's our first step? Convert to moles. Very good. N is equal to M over capital M. Alright, so I have N is equal to my mass of 37, my molar mass, calcium, 40, plus carbon, which is 12, plus oxygen times 3. What does that give me an answer of?
What? The total
0.37.
0.37.
is the moles.
0.37 moles. Right, what's my next step? Ratio. Alright, so I'm using CaCO3 as 2 water, right? Alright, which is a ratio of
1 to
1 as to 1, so that's 0.37 as to 0.37. Now, what's my next step? Convert back to what I want. So I say N, so this was for CaCO3, this is for water. I convert back to what I want. I've got mass, the molar mass, 0.37 for my mass over 1 times 2 plus 16, which gives me an answer of
6.66.
6.66. 6.66 grams, appropriate Halloween number, eh? Alright. So, there's my answer. 5 easy marks. Okay. This is where our 5 marks go. 1 mark for formula, 1 mark for correct substitution. You don't get a mark for calculating this. This just goes into your correct substitution. 1 mark for using your ratio. 1 mark for correct substitution of your ratio. 1 mark for correct substitution over here. 1 mark for your final answer. That's 6. Sorry. 1 mark for correct substitution. 1 mark for your final answer.